Welcome to the course Optimization in Chemical Engineering. In this first lecture of this course, I will try to introduce in a very simple language what optimization is all about. Optimization is important to all fields of discipline. So, it is important for engineers, it is important for scientists, it is important for working personals. In fact, in our daily life, it also plays a very important role. Knowingly or unknowingly, we always perform optimization. For example, when you want to choose a path from going from one place to another, you choose the shortest path. Why? Because you want to minimize the time required for the journey. Or if you walk, maybe you want to minimize the number of steps you are going to take. Sometimes you want to walk more, so that time you deliberately take the longer route. If you have some money and want to put the money in the bank, you would go to the bank which offers the maximum return on your deposit. Similarly, if you want to borrow money from a bank, say for making a house or for some other purpose, you will go to the bank which charges the minimum rate of interest. Suppose you have two friends staying in two different cities of India. You want to visit both of them and you want to plan your travel so that it takes minimum time or your expense is also minimum. So, with two friends staying in two different cities is an easy problem to solve. But imagine you have 20 friends and they are all in different 20 cities of India, and you want to make a travel plan where you want to visit each friend only once and want to minimize the total tour time or the total distance covered or the total expenditure spent on this travel is not an easy problem to solve. So, certain optimization problem we just solve like that and we solve using our past experience. We do not need to have a knowledge or formal knowledge of optimization techniques. Basically, optimization is a set of mathematical techniques that you would like to apply to find out a decision which is best suitable for us. For example, visiting two friends staying in two different cities in India is an easy optimization problem to solve, and you can solve it by using your common sense or past experience. But if you have 20 friends staying in 20 cities, you perhaps will need formal tools of optimization methods to come up with the best solution. You can come up with a solution using your common sense or past experience, but that may not be the best solution. So, what we see from this brief discussion is that optimization is all about making a decision. And when do you have to make a decision? When you have several alternatives. Like, let us again come back to any of these problems that we talked about, choosing several paths or choosing a proper travel plan. So, you have several alternatives and you have to choose the best alternative for you. So, optimization is all about choosing or making the best decision among several possible alternatives. Now, let us look at a formal definition of optimization. So, formally we would like to say that optimization is finding the best candidate or best candidate solution from a set of alternative solutions without explicitly enumerating and evaluating all possible alternatives. So, we will try to achieve or attain the optimal solution without evaluating all possible alternatives. The word optimization originates from Latin word optimus, which means best or very good. So, optimization is the science of making best possible decision. By performing optimization, we aim to obtain the best result under given circumstances. So, why do you want to optimize? In general terms, we want to improve the process to realize maximum system potential. We want to attain new or improved or more efficient designs. We want to maximize profits. We want to reduce the cost of production. Maybe we want to minimize the effect or harmful effect on the environment. In chemical engineering, we would like to perform optimization to utilize raw materials or resources, energy, utility in the most efficient way. Also to reduce waste generation, minimize the environmental impact, to determine the most desirable operating conditions, to determine the safe operating conditions, to meet product specification, to maximize profit. So, the benefits of optimization in a chemical process plant may be improved plant performance. So, in plant operations, benefits of optimization arise from improved plant operation or performance, such as improved yields of valuable products, reduced energy consumption, higher processing rates, reduced maintenance cost, less equipment wear and longer times between shutdowns. So, with these descriptions, we find out that during optimization, we want to maximize or minimize something. Oftentimes, we want to maximize say profit, we want to minimize cost. But it is not necessary that we will be maximize or minimize an economic criterion. We can also maximize or minimize a technical criterion. So, this leads to concept of objective function. So, is the value of the objective function that we would like to maximize or minimize during optimization. We will be talking more about objective function later, but I would like to stress upon the fact that this decision making is based on a criterion which in the language of optimization is known as objective function, and usually we will perform maximization or minimization on this objective function. Let us now look at the picture of this distillation column. So, it is a schematic of simple distillation column with one feed stream enters somewhere in the middle of the distillation column as shown in the schematic. The vapor comes out from the top of the distillation column, is being condensed using a condenser, getting accumulated in the reflux drum. A part of it is being taken out as the top product and a part of it is being sent back to the distillation column as reflux. Similarly, at the bottom of the distillation column there is a reboiler. So, the bottom liquid stream that comes out of the distillation column is vaporized using the reboiler and enters again into the distillation column. A part of the bottom product is taken out as product. Now, what are the optimization that can be performed in this single distillation column? If you have done a course on separation process or mass transfer operations, you have seen that there is an optimum location of feed tray. So, this feed stream has to be put into an optimal location. You also perhaps have seen that using this reflux stream, it is possible to control the purity of the top product. So, determination of optimal feed location, determination of optimal reflux ratio are important optimization parameters in case of distillation column. We will talk about many more such optimization examples throughout the course. So, let us take a look at few more examples of optimization from chemical engineering. Design of heat exchanger network is an important optimization task for chemical engineers. Real time optimization of a distillation column, model predictive control. This is basically a control algorithm, but the control algorithm works on the principle of optimization. So, model predictive control basically uses a predictive model for a process and uses optimization techniques to find out or to establish the control of the process. Operations planning and scheduling is a very important optimization task. Equipment sizing, scheduling maintenance and equipment replacement. Operating equipment such as reactors and columns, you have to design them in the most optimal manner possible. Optimal shutdown, optimal startup of plants are also important optimization tasks of practicing chemical engineers. So, these are just some of the common optimization problems chemical engineers frequently deal with. These are some optimization examples where you have learned from nature. See, the wings of the aeroplane or the design of the wings of the aeroplane has been inspired by the birds. The nose of the high speed train is inspired by the beak of kingfisher. You are familiar with this figure. You must have noticed this figure in your biology book. This shows human evolution, and this shows evolution of our computers, with this being the modern desktop computer. So, let us now briefly talk about the outline of the course. In the first week, we will talk about introduction to optimization. Week 2, we will talk about optimization problem formulation. Week 3 and 4, we will talk about basic concepts of optimization. Week 5, 6 and 7, we will talk about unconstrained single and multivariable optimization. Week 8 and 9, we will talk about linear programming. Week 10, we will talk about constrained nonlinear programming. Week 11, we will talk about applications of optimizations, where we will talk about various case studies and apply the techniques that we have learned till week 10. And finally, in the last week, week 12, we will introduce certain software tools for performing optimization. These are the textbooks or reference books that you can follow. First book is Optimization of Chemical Processes by T. F. Edgar and D. M. Himmelblau and L. S. Lasdon, second edition, McGraw-Hill. Book number 2, Engineering Optimization, Methods and Applications, written by A. Ravindran, K. M. Raxdell and G. V. Reclitus, second edition, Wiley, India. Book number 3, Engineering Optimization, Theory and Practice, S. S. Rao, fourth edition, John Wiley and Sons, Incorporated. So, our discussions will essentially be focused on these 3 books, but I believe you can follow any of these books. The first book, Optimization of Chemical Processes, are written by chemical engineers. The second book, Engineering Optimization, Methods and Applications, also written by at least one chemical engineer, J.V. Reclitis. Engineering Optimization, Theory and Practice by S.S. Rao. This is also a good book, but most of the examples in this book will be from civil engineering or mechanical engineering disciplines. Optimization is not only for chemical engineers. Optimization by itself is a discipline, and this has wide areas of applications. Just to name few: production planning, important for large scale production. You have to choose the best plant site, you have to choose the most favorable operating conditions. Transport and logistics. Optimization plays a very important role in the business of transport and logistics. Important problems are routing of vehicles, like routing of trucks, allocation of empty wagons, fuel transport, etc. Packing problem is another classical optimization problem. Design of cargo space is an important practical problem. Telecommunication, design of network, frequency allocation of a mobile network are important practical optimization problems. Traffic planning, here traffic signal control is an important optimization problem. Structural design, such as mechanical design. Preparing timetable, staff control, staff control of your organization, important optimization problems. Portfolio optimization is an important optimization problem in financial sector, where if you have a good amount of money, you would like to invest in various, say you have various options to invest that money, like say you can buy shares, you can deposit in the bank with certain fixed rates, you can also invest, say, in gold, you can invest in land, or there are other instruments as well. So, how do you manage your funds? How much money you put for buying shares, how much money you put for, say, investing in gold or lands, etc., is an important portfolio optimization. Optimization finds applications in process control. Model predictive control is a good example. Optimization also is widely applied in image analysis, such as, say, photo conversion from black and white image to color image, it finds application. Image segmentation is an important task in image analysis, and optimization is also used there. So, these are some optimization applications from different areas, not necessarily chemical engineering areas, but for different areas. I just wanted to stress upon the fact that the scope of optimization is very, very wide. So, let us take a look at plan for the first week. So, lecture 1, in this lecture 1 we try to introduce very briefly what is optimization, what is the motivation for optimization. We introduce the textbooks. In lecture 2, we will talk about statement of optimization problems and classification of optimization problems. Lecture 3, we will take some examples of engineering applications, and lecture 4 and 5 we will review linear algebra, particularly matrix algebra, and some of the linear algebra that may be required for learning optimization techniques later in the course. So, with this I would like to stop here lecture 1.